Okay, today we're going to dig deep, and I mean literally, into one of the most overlooked but absolutely essential parts of the entire energy industry.
So, let me ask you something. When you picture a huge drilling rig, plunging miles into the earth, what do you think is the most critical fluid in that whole operation? I bet your first thought is the oil itself, right? The black gold they're after?
Well, you'd actually be wrong. Believe it or not, in the day-to-day, moment-to-moment reality of drilling, the most important fluid isn't the one they're trying to find.
It's the mud. And I'm not talking about the stuff you find in your backyard. No way. This is a high-tech, meticulously engineered fluid that can literally make or break a multi-million-dollar drilling operation. You can think of it as the secret lifeblood of the whole process. It's this complex mixture that has to do several incredibly important jobs at once, all while being thousands of feet underground, under insane heat and pressure.
So what's it actually do? Well, as that drill bit is just grinding through solid rock, the mud is being pumped down to cool and lubricate it. It's also creating enough pressure to stop a dangerous blowout. And maybe most importantly, it's what carries all that pulverized rock, they call them cuttings, all the way back up to the surface. Without it, the whole thing would just seize up.
And this, right here, is the perfect analogy. It just nails the stakes involved. If that mud recipe isn't perfect, the consequences are, well, they're severe. You'd never pour sand in your car's engine, and for the exact same reasons, you can't afford to have bad mud on a rig.
So what happens when things go sideways? Well, if you have too many solids, they can form this thick mud cake on the walls of the well, and that just slows everything down. If it gets too thick, the entire drill pipe can get stuck solid, and that's a catastrophic failure. We're talking millions in downtime. And any abrasive particles, like sand, act just like sandpaper, wearing down all this super expensive equipment. It just makes the whole operation slower, more expensive, and a whole lot more dangerous.
Okay, so how do you make sure the mud is just right? Well, it all starts with the most basic, but maybe the most important check of all, testing for sand. This is your first line of defense against that gritty, abrasive enemy.
And the tool for the job is this, the Sand Content Kit. It looks pretty simple, and it is. It's designed for one purpose and one purpose only: to answer the question, how much sand is grinding away in our drilling fluid?
The process itself is really elegant in its simplicity. You just take a sample of mud, shake it up with some water, and then pour the whole mixture through a superfine screen. The mud and water wash right through, but any sand gets trapped. Then you just wash that sand into a measuring tube, and that's pretty much it.
The sand settles to the bottom, and you can literally just read the percentage of sand by volume right off the markings on the tube. It's quick, it's clever, and it's a super reliable, low-tech way to get a vital piece of info right there on the rig floor.
But sometimes just knowing the sand content isn't enough. Drilling mud is a really precise recipe. It's got water, oil, and all sorts of other solids. If that recipe is off, you need to know exactly what the balance is. And that's when you bring out the big guns for a full workup.
Say hello to the Retort Kit. The easiest way to think about this thing is like a miniature distillery. Its whole job is to take a mud sample and basically boil off all the liquids, separating the fluid into its core parts: oil, water, and solids.
So here's how it works. You put a sample of mud in this steel cup and heat it to over 900 degrees Fahrenheit. The oil and water vaporize, then they travel through a condenser tube, which cools them back into liquid, and then they just drip down into a special measuring tube. All the solids, they're just left behind in the cup.
And here's the cool part. Because oil is lighter than water, they naturally separate into two distinct layers in that collection tube. So an operator can see, with incredible accuracy, the exact volume percentage of oil and water in their mud. And then by just subtracting those numbers from the original sample size, they know the exact percentage of solids too. It's a complete chemical breakdown.
Now, the Retort Kit works great, but it's also kind of slow and a bit complicated. And in the world of drilling, time is always money. So, of course, a new technology was needed.
And wow, what a leap it was. On the left, you've got the Retort Kit, heaters, condensers, all of these different parts. On the right, you have its modern replacement. It literally went from a chemistry experiment to a portable, handheld device you could take anywhere.
The difference is just it's night and day. The old Retort Kit needs that whole heating and condensing process, which can take, 20 to 30 minutes. The new Mud Checker, it's a total game changer. It uses radio frequency sensors. You literally just dip the probe into the mud and, boom, you get an instant reading for oil, water, solids, even salinity. It's faster, it's simpler, and it's completely portable.
So, we've looked at 3 different ways to analyze this incredibly important fluid, from a simple sieve all the way to a high-frequency sensor. But let's pull back and put it all together, and remember why this is all so important in the first place.
Each method really offers a different balance of detail versus speed, but they all serve the exact same goal: to maintain the perfect drilling mud. Whether it's a quick sand check or an instant full analysis, it's all about quality control.
Because in the end, every single test, every measurement, every percentage point, it all comes back to this. Analyzing the mud is what prevents those catastrophic equipment failures. It saves huge amounts of time by making sure the drill is running as fast as it can, and it makes the entire operation safer for every single person on that rig.
It's kind of an incredible thought, isn't it? Our high-tech world of energy exploration, with all of its massive power and complexity, depends on something as humble as, well, mud. And without that hidden science to get the mud just right, the whole system, from the drill bit all the way to the gas pump, could quite literally get stuck.